All right, fantastic. So today is Wednesday. We do algebra. Last thing that we did was binomial expansion. Let's do a recap. Okay? And then now I think the next topic is going to be algebraic fractions. Okay? So we're still going to be on distributive law, but we are going to be pushing the boundaries of that a bit further. But as a recap, let's go. For those who weren't here, what we did last week, Wednesday, was it? What we did last week was binomial expansion, and we had said that given that x plus 4, example, multiplied by x minus 2, for example, and you're asked to expand and simplify. We said that these expressions are inseparable. So because the brackets are there, it implies that you need to multiply this bracket by that bracket. So you cannot take the x from this bracket and group it with the x with that bracket. You're not adding or subtracting. Now had it been no brackets here, if there were no brackets here, and a sign was here, then you could just organize it. X is x, number with number. But there's a bracket there. Once there's a bracket there, we're going to take the first term, which is the x, and then we're going to multiply it by the bracket that is to the right. That's x take 2. Then you're going to take the second term, which is 4, and again multiply it by the bracket to the right. So notice that the second bracket repeats itself, and we split the two terms in the first bracket. So first term multiplies second bracket, second term multiplies also second bracket. We distribute here, x times x, x squared, x times minus 2, minus 2x, 4 times x, 4x, 4 multiplied by minus 2, minus 8. And as we said too, that this is the kind of expression where most of the time, if it's written in the standard form, most of the time, the like terms appears in the middle. Most times, not all the time. Most times it will appear in the middle. So we have x squared, and then what is minus 2 plus 4? Minus 2 plus 4? Positive. What's the negative 2? We have nothing. You have O2 or you have 4. You have P or you O, you have 2. Don't let me know nothing. Minus plus 2, minus 8. And that expression there becomes your simplified expression. Okay?
Sir, can you work it to the side? I'm not able to see the word.
I apologize. I'm going to work on it out. So x squared plus 2x minus 8. Now this expression here has a special name. Did I tell you what it was? Did I mention it? I might have mentioned it. I had said that we're probably going to get to it soon. It's called a quadratic. Okay. So that topic is coming up. So when you hear the name again, don't act like it's the first time you're hearing it. This expression is called a quadratic expression. And when we get to that topic, you'll know why. Okay? Let's do another one for the class. Not erasing. Expand and simplify. Two x minus 5 with 3x plus 2. What's the first term in the first bracket? So we drop that down and we will multiply that by what? Multiply it by the second bracket, which is 3x plus 2. What's the second term that is in the first bracket? Negative 5. And we multiply that by the second bracket, which is 3x plus 2. Have that? Did? Okay. Distribute, distribute. Oops, don't like that. Distribute, 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 distribute. Distribute means to multiply. So we're distributing the 2x with the 3x and the 2. So the 2 multiplies the 3 and gives you, and the x multiplies the x and gives you x squared. The 2 multiplies the 2 and gives you 4, but there's nothing to multiply this x. So the x comes back down. Yes? The minus 5 multiplies the 3, gives you minus 15. There's nothing to multiply the x, so the x comes back down. The sign also has to be distributed. So minus multiplied by positive gives you a minus. 5 times 2 is 10. Once again, the like terms appear in the middle. Once it's written in the standard form, x number, standard form, it's going to always appear in the middle. So therefore, then we end up with 6x squared, nothing to add to that. What is 4 take away 15? Very good, negative 11. X minus 10. And that there becomes your simplified expression. You've expanded it and you've simplified it down to that. So that would have been the introduction to it. That is how you do it, but you have to be able to see it in a longer version of a question. Okay? This is going to pop up in the middle of a question at some point. So we're going to look at that. That was the question that we had. We did that. It was the last question we did in the last class. Yeah, man, I did it right here, and you guys were a bit silent for a while. Not this, you know. We did the question I'm going to do now, where we merge both of them, basic with this, and it looked a little bit long. You guys look a little bit blue. May I erase the middle? May I erase the middle? No? Put it on that side? Can I go on this side as well?
Yeah.
So just don't go in the middle there. Alright, no problem.
Answer in the video when you're writing on the board, or when you're writing on the board, I'm not able to view it.
The light.
Yes.
I'm going to have to put an overlay shadow over it. Thank you. This light is affecting me.
Sir,
Yo,
use the middle.
I can use the middle?
Yeah.
Okay.
This side. This.
So middle and right side, yeah? Okay. May I erase here? Can I erase? As I was asking, can I erase? No one was answering me. Alright, so expand and simplify. Expand and simplify. Alright, so 2x minus 4 take away 3 open bracket 4x minus 1 times 2x minus 5. Something like that. Similar to that. Okay? I can't give you all the examples in the world. I can't. I can only give you aspects of it, you know, things that may pop up. Okay? Let's put something here. Should I? I'll put this thing. It's good. So we have an expression to expand and simplify. Some other stuff is attached to the binomial expansion here. And my advice to you is, no matter where the expansion is, whether it's at the end, in the middle, or at the front, anywhere you see this double bracket, deal with that part first. Okay? Don't mess with anything else. Don't try to add or subtract anything else. So I'm going to write my 2x, pause attention. Okay? I'm going to write my 2x. I'm going to write down back my minus 4. I'm going to write back down my minus 3. And then I am going to distribute and expand that. The temptation would be for you to do this and do that, and if you do it, that can work. But then you're gonna still have to do the expansion anyways. I recommend that you do the expansion first, the double brackets like what we just did here, and then you do the final distribution. That's my recommendation. Okay? So I'm not going to distribute the 3 as yet, I'm going to wait. I need to get rid of the double bracket here. So I rewrite my 3, I put a square bracket here, and then I'm going to work out this part. What's the term that I bring down first? Not hearing everybody, you know. Bring down the 4x. Don't worry about these, they're going to come down. Okay? And focus on here. You just did an example like this. Here, the same process you're applying. You bring down the what?
4x.
Very good, and you open a tiny bracket inside. Not true? And you multiply it by 2x take 5. Not true? Then now the next term you bring down is what? Negative 1. And then you open the bracket and multiply it by 2x take. Close that curved bracket, close that square bracket there. Our only concern is to get rid of this double bracket here. Okay? So I bring down my 2x here. Take 4, take 3. Sir, why you cannot take away the 4 from the 3? The 3 from the 4 now. But you cannot subtract before you multiply. Said it already. So don't do that. Open the square bracket here. Why are you using a square bracket? What's the difference between a square bracket and a curved bracket? There's no difference. I just use them to separate, okay? I'm already using a curve in the inside. So I'm going to use a square on the outside. And if I have to use another bracket, I'm going to use the curved one. So it's to distinguish, to separate my different operations. So now, everything is written back here. I distribute. Okay? Let's distribute. That with that. That with that. That with that. That with that. Okay? 4 times 2. 8, x times x, x squared. Yes? 4 times 5, sorry, 4 times minus 5, minus 20, x, yes? There's no x to multiply here, so we're good. Take away 1 times 2x, 2x, correct? Negative times negative, positive. Right, Ms. McLean? The experience one sign cost you several marks, did it? Okay. She knows. One wrong sign costs you marks. You make a mistake up here and you're dead. That's it. Okay? Alright, so now we end up with one. So now only one final bracket we have left now. You have a choice. Personal preference now. Do you want to distribute the minus 3 or do you want to simplify inside first? It's up to you. I'm waiting for you, no? Simplify first. Get this down from 4 numbers to become 3. Okay. So 2x, take away 4, take away 3. Yes? Open bracket. 8x squared. What is minus 20 minus 2? What? Who's the positive? Let me have things. Minus 20 minus 2? No. Negative 22. Person who said negative 18, stop subtracting and writing the sign. This is not 20. This is minus 20. So do not say 20 take away 2 and then write down what the sign. Incorrect. You made a mistake there, I stop marking. you owe 20, and you owe 2, you owe 22, plus 5. Good. Finally getting the answer. Oh,
Sorry.
finally getting yes.
You have negative 20x and negative 2x.
Yes.
So why you only have 22x? Is it 22x squared?
No, when you're very good question. When you're adding and you're subtracting, we do not interfere with the powers. The only time the powers get involved is when you're multiplying. So leave the powers alone, the x just comes back. Okay? When you're adding and subtracting, the focus is only on the coefficients, never with the powers. It's a good question. Okay? Now, we're almost done. Alright? We have to distribute what? Do I distribute the 2x, the minus 4, or the minus 3? Which one do I distribute? The minus 3. Rule says that what? We distribute what immediately precedes the bracket. You said that, right? Good. So this 2x, take away 4 comes back down. And we distribute here, here, and here. I don't like how that looks. On time. That. Much better. So 2x, take away 4, minus 3, multiplied by 8 is minus 24, x squared. The term comes back down. I do not interfere with the powers. Negative times negative is positive. Not true? Pardon me?
Multiply negative 3 by...
I'm distributing the minus 3. Okay. 3 times 8, 24. Negative times negative is positive. 3 times 22 sounds like about 66. X. I do not interfere with the variable. Negative times positive, negative. 3 5s, 15. So all the brackets are gone now. So now that all the brackets are gone now, we just need to tidy it up now. Look for all the x's, all the numbers, all the squares. The order in which you write down your answer doesn't matter. So if you want to group the x's first, it's up to you. Numbers first, it's up to you. Squares first, it's up to you. I like writing my answer in descending powers. So I like my highest power first. So there's no other square here, so my final result is minus 24 x squared. Are there any more x's? Look good enough. Look good enough. Are there any more x's?
Yes, sir.
2x and 66x is what? Yeah, so 68x. That's plus 68x. So that gone, this gone, what left? This and this, right?
2x.
So minus 4, minus 15 is? Minus 19x. Sorry, minus 19. And that there is your simplified expression. Okay? It doesn't come up a lot in CSEC, but when it does, you know, students flunk it. So we're not going to spend too much time on that because, like I said, it rarely comes, but when it does, it comes back 54 or 5 marks. So you just want to make sure that you can at least get yourself to around this point. Okay? Alright, so that is the distributive law. Please look out for it. It's going to come up again and again and again. Okay? Binomial expansion, the distributive law. Now we have to move along. Okay? That was our nice little recap. Now we have to move along. We're going to be moving on to algebraic fractions. Still distributive law, but a different variance of distributive law. So head up that for me, algebraic fractions. Your face, you look bewildered. What happened? Okay. I thought it was something that I did funny. No? don't know everybody in the class here. Oldness, Brooks, Donovan, Malaysia, Stillmula, Sweden, Stillmula, Sanjay, Stillmula, McLean, Ruben, Nardi, Hansen, Whiteley, Morrison, Antonisha, Kiwi, Miriam, Alicia, Lindsay, Roshana, Melissa, Sanika, Roach, Ashnik, Burns, Listening, Simone, Stick. I get it. May I erase? May I erase? No? So, algebraic fractions. Alright, now to keep it very simple then. Keep it very simple. The same way how you would work out fractions when I just met you, is the same way you're going to work out algebraic fractions. With the exception that when you work out a numerical fraction, you get an answer like a half, 2/3, 3/5, stuff like that. All the rules apply for fractions, applies for algebraic fractions. Okay? It's just that your answer is going to be an algebraic result, an expression. It won't be a half, it might be a half x. It won't be 3/4, it might be 3/4 y. Something of that sort. Okay? So, what do we do when we're adding and subtracting fractions? What's the rule? You find it? Same rules for algebraic fractions. Once you're adding them, you're going to find the LCM. What do we do when we are multiplying fractions? We cancel out. Not sure? Find things to cancel, factors to cancel, and if nothing cannot be cancelled, then we multiply across. When you're dividing fractions, what do we do? Change the divisor and change the sign to? The rules not change. Everything remains the same. So I don't need to give you a definition. Okay? Just need to get into it. So 1, start off simple, no more my style. Okay? Simple we are starting. X divided by 4 plus x divided by 3. So the x divided by 4 plus the x divided by 3. LCM. Not true? Same like how you broke up. What if this was 1/4 plus 1/3? X is just representing a number. It could be any number. 3, 4, 5, 6. So x/4 plus x/3 is like saying 1/4 plus 1/3. The LCM is what? 12. 4 into 12. You put the result at the top. 3 into 12. Put the result at the top. What is 3 times x? What is 4 times x? Are we allowed to add terms that are alike? So 3 plus 4 is what? 7x over? Voila. That's it. That's it. 7x over 12. So that's one example. Addition. Now I'm taking it for granted. I'm going to still assume that you guys will mix it up. Okay? So I'm going to give you a subtraction only. 2. Sidonia, see in the middle? Am I too much in the middle? Am I too much in the middle? Okay, good. 2. 3x over 5 take away 2x over 7. And you're asked to simplify that. Okay? Write your answer. They like to say, write your answer as a single fraction. That's what they like to, that's the instruction. Write your answer as a single fraction. So the LCM, right? That's the rule is when you're adding and you're subtracting, you find it? Okay. 5 times 7 is 35. How many times will 5 can go into 7? Sorry. How many times can 5 go into 35? Give away the answer. Silly me. How many times can 7 go into 35? Beautiful at the top. 7 times 3? 21. X. 5 times 2? 10. X. Are we allowed to subtract terms that are alike? So 21 take away 10 is 11 over 10. Do not turn it into a mix over 35. Thank you. That was a genuine mistake. 11x over 35 or 11 over 35x. Okay? Do not try to turn it into a mixed fraction even if you get one. Don't do mixed fractions in algebraic fractions. Okay? Whatever you get, that's it. Okay? So 11x over 35. So we look at the rules for addition. These are all reminders now. These are all reminders. We've done fractions in its entirety. So the only thing that I'm doing here is that I'm replacing my numerator with a letter. Not much change. Okay? Now is it a case where my denominators will always be a number? No, it becomes a number. This is where the algebraic fraction comes in now. Because with fractions, your numerator and your denominators are always numerical. But with algebra, your numerators can be letter variables and your denominator can be variables. So let's look at an addition subtraction example with the denominator being a variable. So let's say that we end up with 3 over x plus 5 over 2x. Get into the 2y part. Get into it. Keeping it simple for now. So, when we were doing fractions, I had said to you that one of the easiest ways to find the LCM is to multiply the denoms. But if you do it this way with algebraic fractions, you're going to be expand. Oh wait, I'm not sure the word. You cannot multiply these two. Okay? No. Okay. You have to look at finding out, can this term go into this term? Okay? Or put it this way. You can to an extent, but we don't want you to multiply it and get a result. So the LCM here would have been x by 2x. That's the LCM. So you put both denominators together, but do not multiply them to get a result. Okay? I don't even like it like that either. I don't even want to do it like that. Because you see, x repeats itself. So x is the denominator and 2. Because x can go into 2x and 2x can go into 2x. So the LCM is 2x. Okay? Alright. Pay close attention. X, knock out x and leave it with times it by the top. Catch that, Miss D? So the x here divides into this 2x and leave it with, so you multiply by the top.
Sir.
Yeah.
Okay, so x, so you get to what is x into x goes to
Yes, x into 2x goes 2 times.
oh, 2x.
So x into 2x goes 2 times. And then 2x into 2x is like asking 10 into 10. Both times by the top. 3 times 2, 6. 1 times 5. So 6 plus 5 is 11 over 2x. That's the result. So the trick in this question is to get the right LCM. But just to avoid you making a mistake, the advice is do not multiply them. Okay? Do not multiply them.
Sir, is it a case where you could use 1x?
As the LCM?
No. Where to represent the x?
Here?
No. X
Here.
itself.
Here.
Mm-hmm.
Use 1 to represent the x?
As in 1x.
Yes. You can.
Also, 1x.
So 1x here is like saying what is the LCM of 1 and 2? 2. What's the LCM of x and x? X. That's a nice way to look at it.
Makes sense.
So you can find the LCM of the numbers, put it down, and find the LCM of the variable. That's a nice way to look at it. Never ever think about it like that. That's good. Let's do another one like that. 4 divided by x, take away 2 divided by x cubed. Tricky one. So in the event that you get something like this, how do you handle a situation like this? 4 over x, take away 2 over x cubed. Does anybody have any idea what the LCM might be? Would it be x or would it be x cubed? I heard someone say x to the 4. Do not multiply them. Has to be x cubed. Why? Because you're sure you can get 1 x's out of 3, but you can't get 3 x's out of 1. So a simple way to put it is that the LCM has to be the variable with the highest power. Make sense? The LCM has to be the variable with the highest power. So if this was x6, what would be the LCM? x6. If this was x2, what would be the LCM? Very good, x3. And if this was x squared, what would be the LCM? X squared. And what would be the LCM now? X. So basically it has to be the variable with the highest power, if the variables are the same. Okay? Talk to me. Who said that?
That we are dividing, right? X cubed and the LCM.
Yeah.
I have to divide so much time I can get x by itself. When do you remainder?
Okay, so x cubed divided by x, which is what we're doing. When we say, I'm going to answer your question. When we say x into x cubed, it's the same thing as what we say x cubed divided by x. So watch me now. How many x's at the top? Talk to me now, guys. 3. How many at the bottom? 1 knock out 1, leave how much? So you multiply the top by x squared. Catch it? So 3x is at the top, 1 at the bottom, 1 at the bottom, knock out 1 at the top, leave you with what? 2. So the result multiplies the top. Always multiply the top with the result.
So it's simple like you're taking away the x from the x squared.
That is correct. Because
Find you take away the x from the x cubed, then you end up with the x squared.
right.
And in which you're going to use the x squared to
Multiply the 4, the numerator, yeah.
the digits.
Yes.
Sir,
Yes.
if that will instead of multiplication, sir.
Oh, sure, no problem. Better?
Yeah, x.
Okay. Alright? And remember, it's the rules that we're using that you learned earlier. Now, when you're dividing, what do we do, sir? Subtract it.
Huh?
When we're dividing, what do we do? Subtract the powers. Missed that class? Okay, so I'm trying. So when you're dividing, you subtract the powers. The power here is 1, the power here is 3. Subtract, we get 2. How many times can x cubed go into x cubed?
1.
Beautiful. So your times divided? Done. So what is 4 multiplied by x squared? 4x squared. What is 1 multiplied by 2? 2. Are we allowed to subtract 2 from 4x squared? We can't do that, right? It's numerical algebraic. So our answer is what? 4x squared, take away 2 over x cubed. That's it.
So I don't get the part with the 2.
Here?
It times the 1.
X cubed into x cubed is like saying 10 into 10. Goes 1 times.
So sir, you have to go back here because you already got the x squared to multiply the numerator. So why do you have to go back to use the x squared to cancel again?
Let's go back to the basics. 1 divided by 4 plus 3 divided by 5, 20. Let's go back to basics. 4 into 20, 5. Why am I have to go back into the 20? I already went 4 into 20. So why am I putting 5 into 20 again? If you have the answer to this, you have the answer to this. The x goes into the x cube is for that term alone. So you have to leave it that term as well.
Okay.
So x cube goes back into x cube again, times by the top. Remember, you're doing the same thing you did when it was numerical. Nothing now changed, except you're just dealing with variables instead. Okay? Also, we're done? That's it. Alright. So you have an expression like that, then you're asked to simplify that one. So you find the LCM. Now because the terms at the bottom are unlike, now you have to multiply them. Morrison? Now that the terms at the bottom are unlike, that's when now you have to multiply them to get the LCM. Because the terms at the bottom were the same base, then we have to leave them alone, yeah? But they're different. So now the LCM is what? 5 times 2 is? 10. Y. Make sense? Good. Now, how many times can 5 go into 10? So one at a time, 5 into 10 goes 2 times, and the y comes up. Because nothing cancels the y. So 5 into 10 2 times, and the y goes up. That's good.
So
2y.
So 2 into 10.
Oh, this one, okay. So 2 into 10 goes what? 5, and the y cancels the y. Morrison? The y cancels the y. Okay? So it's just 5 alone left. Nothing cancels the y over here, so the y went up. But the y cancels the y, so only 5 goes up. Alright now. So we have 7x times 2y. What is 7 times 2? 14. X times y is xy. And then of course 5 times 5 is? But we can't really do anything to that. Can we? The terms are unlike. So our answer, simplified version is 14xy take away 25 all divided by 10y. That's it. So in a nutshell then, let's summarize. Now these are not the CSEC ones, these are just some little ones that will pop up on you. Okay? We'll show you the CSEC questions in a moment. So in a summary there, when the denominators have similar bases, okay? Choose the base with the highest power. When the bases are different, multiply them together. When it's numerical, yes, you multiply them together as well. Okay? Now we did say that we are connecting, because we're on algebraic fractions. Okay? We looked at when the denominators are letters, we looked at them when they're numerical. Okay? So we're going to connect what we did last week, Wednesday, with what we're doing now. May I erase the middle? So instructions on the paper is going to be simplify the expression below. And here's the CSEC question then, or the exam structure question then. Let's call it that. 2x take away 4 over 3 plus, let's go plus first. 2x take away 4 over 3 plus 3x minus 1 over 2. And you're asked to simplify that. That's what you're going to see on an exam paper, most likely. It's still a fraction, ladies and gentlemen. It now will change. 2x take away 4 divided by 3 plus 3x take away 1 divided by 2. Fractions remain the same, yeah? So the LCM is what we're finding. Not you?
Sir, what is it? A 7x take away 1?
Oh, 3x. Bad handwriting. 3x take away 1 over 2. So it's a fraction. Please bear in mind that they're not going to necessarily tell you that simplify the algebraic fraction below. No, they're not going to do that. They're going to say simplify the expression below. At most, they might say write your answer as a single fraction. That's the most clue you're going to get. So you find the LCM, because an algebraic fraction is a numerator over a denominator, but because it's algebraically written, there is a letter involved. Okay? The LCM is what? 3 times 2? 6. How many times can 3 go into 6? 2 times. You write down the 2, and you open the bracket and bring down the top. So 3 into 6 goes 2 times. Bring down the top. Sir, do I have to bring down the top? Not necessarily. The thing is, when I say 3 into 6 goes 2, some of you guys will multiply the here by 2 and forget to multiply the 4 by 2. And because you forget to multiply the 4 by 2, answer incorrect. So I kind of encourage you, or I recommend, right? If you're in tune with the math like that, okay, you can go ahead and be like, okay, 3 into 6 2 times, and then 2 times 2x, 4x, 2 times 4, 8, you know, if you know what you're doing. I don't recommend it. In the next example, I'll show you why I don't recommend you doing it. Okay? For this one, you'll get away with it. I prefer that you write it down. Okay? Plus 2 into 6, 3, multiplied by the top. Are we good? Everybody cool? Everybody cool? Okay. Next then, on this line, Ms. McLean, this looks like something that we just completed last week, Wednesday. Distribute, 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 distribute. Once there is anything outside of a bracket, it has to be used to distribute to what is inside the bracket. So 2 times 2x is? And 2 times negative 4? Negative 8. 3 times 3x is 9x, and 3 times minus 1 is minus 3. And everything goes all the way back over 6. That over 6 comes all the way down. Or a little bit untidy. So we need some grouping. Now if you want, you don't have to group it. You can do it in your mind, mentally. So I will just look at this and be like, oh, this and this is 13. And this is minus 11. But then again, as we say, it's best if you write it down. 4x plus 9x minus 8 minus 3 all over 6. Takes literally 15 seconds to rewrite that. So 4 plus 9 is 13. X. If you owe 8 and you owe 3, you owe 11. I will say 5. One may have things. One may have things. You owe 8, you owe 11. Sorry, owe 8, you owe 3, you owe 11. And that is all over 6. Result. 13x minus 11 over 6. Yep. Yeah. Sometimes the minus sign affects the sign. So you might just make a mistake and carry on this sign and cause. So you can't do this way, remember, when you do this way, make sure the sign of the sign. If it's a minus here, it will change from this. So you can remember that, no problem. Now earlier, I said to you that I kind of prefer if you guys write it down on the line, because sometimes this sign, whatever is here, will affect what is over there. And so like I have a student that he was like, okay, 3 to 6, can I do it like this? Like that, like that, like that. Yes, you can. You can, of course you can. But just remember that your signs can be affected. Next example, let's look. 4x take away 1 over 3 minus 2x minus 5 over 4. So same procedure, nothing changes. It's a fraction. Find the LCM. Is that clear? LCM is 12. How many times can we get groups of 3 from 12? 4. I prefer writing it down, honestly. And how many groups of 4 can we get from 12? How many groups of 4 can we get from 12? 3. So 3 open bracket 2x minus 5. On the line, looks familiar. Whatever is on the outside of the bracket should be used to multiply what is on the inside of the bracket. So there, there, here, and here. 4 times 4x is 8x. Sorry, pardon me, 16x. Thank you. 4 times minus 1 is minus 4. That's true? Here is where it might cost you. Minus 3 times 2x is minus 6x. And most of you guys forget to distribute the sign. You often say 3 times 5 and write down minus 15, and that's where I have to stop marking. I'll probably only give you 1 mark, because this minus here was affected by this minus here, so it become a plus. So minus 3 multiplied by minus 5 gives me positive 15. So down here, you don't get the x part right, you're going to get the numerical part incorrect. Okay? And this is all over 12. Okay? So let's group. As I said, you don't have to do all of that fancy stuff grouping. When I'm doing it, I skip from here, go all the way down here to you. That's how I do it. Okay? But you're learning. Okay? So I recommend that you group. 16x, take away 6x, take away 4, plus 15, all over 12. 16 take away 6. 10. X, is it?
Where?
Okay. What is negative 4 plus 15? It's negative 4 plus 15. 11. So that's plus 11 over 12. That's your answer. Can't go no further. You get it? You get it, you get it, you get it. Give me a time check. Right, 6. Alright, so I think with a little practice you guys should get the hang of that. But is that the only way? That's just it? No.
Yes, sir.
Oh yeah, you can get 3 of them. Yes, dear.
That's how do you get the negative 3 from that?
Negative 3 here.
Yes.
4 into 12. 3 times.
Mhm.
The minus comes down.
So you don't treat this sign as is
No.
there.
No. 4 into 12. This sign comes down. This sign comes down. And 4 into 12. 3. Good? Sign comes down. 4 into 12. 3. Good.
Or did you treat it that way?
How did you do it?
I did the 4 times the 4. I just multiplied it with that second stage, and then I have 16x minus 4 minus 6 minus 15.
Minus 15.
Yes.
So the sign outside affects the sign inside. Sign outside, remember we said this in the beginning of distribution law, that when you're distributing, you have to distribute not just the number, but you have to distribute the sign. So the minus sign here affects sign and sign.
But in the order that I did it, sir, it wouldn't have become a negative 3.
Walk me through
3
it.
would have still remained.
Walk me through it. So you have 4x take away 1, can't take too much time to do that. Minus 2x take away 5 over 4. Let me think what way you might have gone wrong. So you found the LCM, which is?
12
Good. You said 3 into 12.
times the 4.
So how did you write it up here? Did you put
Yes.
a bracket?
No.
So you times it by it?
4.
And here? Is that what you did?
Yes.
Alright, fair enough. That's what my friend here was doing. Oh, it's wrong. And you said 4 into what?
So it's 12 3 times.
So you times it by 3 and times it by 3. Not sure?
Yes.
Alright, so you said 4 times 4, x is what?
16x.
And 4 times minus 1 is
4.
minus 4, right?
Yes.
And what did you say now?
So just put back the sign in the middle.
So this sign here, so you put the sign here?
Mm-hmm.
But this sign is for these 2 minus 3. This sign here is for this minus 3 here and this here. Okay? So it's not just 3. Because technically what we're really doing now is that we're saying negative 4, if you want to become technical with it. If you want to become technical, we're saying negative 4 into 12 goes negative 3 times. If you want to become technical. Okay? That's really what is happening. Alright? So yeah. So just, if you're going to do that, just remember that the sign will affect it here. Hold on. I think I can last. I think I should be able to last. I think I can last. Alright, so good. But that's a good observation, because as I said, the mistake that she made is a mistake that's made by a lot of students. Right? And keep forgetting that sign. So it's good to get some clarity there. Alright? Alright, let's push the boundaries of this thing. 4 divided by x minus 1. 4 divided by x minus 1. Take away 5 divided by 2. 5, sorry, x divided by 5. And you're asked to simplify this. So 4 divided by x minus 1, take away x divided by 5. It's not a different math. And the same principle, not much change. As long as it's algebraically written and it's a fraction, all the principles still apply. You find the LCM and do your thing. In this case then, I'm thinking like you, I'm thinking that the issue will be you finding the LCM. You can be like x minus 1, isn't x 1, so 1 minus 1 is 0, or you're thinking of different things. Okay? When your denominator is an expression, whether it be binomial or monomial, once an expression, we don't interfere with it. We simply merge them together. So my LCM here becomes 5 open bracket x minus 1. And I put the 5 beside the x minus 1. Huh? Say that again before I come from say.
X minus 5. So 1 divided 5 times 5 by 1.
Here?
No, and the top one.
Oh, you're going at the answer now? And you're working it out now?
The bottom part.
Yeah.
Instead of having 5 bracket x negative 1.
Mm-hmm.
We don't have x negative 5, so the answer is 5 1 5. So it's like x 5. X
Oh, 5x. 5, okay, so 5x take away. Is that what you're saying?
So,
Are you saying that I should go inside the bracket and simplify?
yes, sir.
Oh, if you do that, well, you can. But then you have no way other, because if you go inside, you won't be able to see how many times this go into this. So I would recommend that you go inside the bracket. Okay? Alright, let me show you. I'm gonna, question to you. I'm coming to you, Sedona. I'm going to show you an example from a fundamental perspective why I do it like this. Sedona, question.
Does it matter if you put the 5 before the
No,
bracket or the-
it doesn't. Multiplication is commutative. Alright, Antonisha, back to basics. Every time a problem gets challenging, back to basics. 1 over 4 plus 2 over 5. What's the LCM? 20. The reason why we can do this is because we know numerically how many times 4 can go into 20 and how many times 5 can go into 20. But to look at this and be like, okay, how many times can x minus 1 go into 5x minus 5? It's difficult. So if I don't want to say 4 times 5 is 20, I could just simply say 4 by 5. And so 4 into 20 goes. So we are able to, when we do it like this, we are able to see exactly how many times it goes into it. Let me say that again. When we say 4 times 5, LCM is 20. Because we've been doing math, some basics, okay? It's easy for us to visualize how many times we can get a lot of 4 or a lot of 5 from 20. But when you do it like this, it makes it even clearer, because the 4 cancels the 4 and goes 5 times, and the 5 cancels the 5 and goes. So when you do it like this, you can clearly see this is a technique we use when it's algebraically written. Because when it's algebra, it's very difficult for you to visualize how many times can a binomial expression go into another binomial expression. It's not numerical, you can't see it. So with this, when we do it like this, we can safely say, how many times can x minus 1 go into this product? So that knock out that, leave you with what? 5. You can clearly see it. X minus 1 goes into this product 5 times. Okay, times up at the top. And watch now. The 5, knock out the 5 and leave you with what? X minus 1. So you put this up top, x minus 1. Marcy, see that? Okay, everybody? So this, knock out this and leave us with 5. And the 5, knock out the 5 and leave you with x minus 1. Okay? What is 4 times 5? 20. Not true? And this is the distributive law again. Because once we have something on the outside of our bracket, as a matter of fact, let's write it down. 4 times 5 minus x bracket x minus 1. Let's write it down. Let's write it down. 4 5 is 20. X times x. X squared. X times, whoops, make mistake. This person can correct me.
I'm not paying attention.
4. I already said that. I already said that. I come with 5. 4 times 5 is real. Who would you talk? You're gonna say, 4 times 5 is 20. Watch now. Negative x times x is negative x squared. Burns. Negative times negative. Positive. X times x is, sorry, x times 1 is x. We good? 4 times 5 is negative x multiplied by x is negative x. Negative times negative is x times 1 is x over 5 open bracket x minus 1. Can we do anything to the top?
Yes, sir.
What are you gonna do? X squared, x, 20. You're all on that. You're all on that. So my answer is what? What you see there. My answer is 20, take away x squared plus x all over 5 open bracket x minus 1. So there are different variations of fractions you can make. Like I said, there's levels to it, you know. For CSEC, I have not time. Have I? You're going to see this more often than not. This one, particularly. Okay. Everything else that I've shown you are just things that might be what I call a curveball. You're going to exam, and you plan for that question. You know you're going to look it down if you catch it. And then swing a curveball, one question we never expect, none at all. Okay? So it's good that we can touch base, so you get familiar with how to attempt some of these questions. Okay, alright. Give me a time check. So we can just touch a little bit of multiplication, not multiplication. Alright, so we've completed the addition and subtraction. The rule is simply what? Find the LCM. Okay? We've looked at when the LCM is numerical. We've looked at when the LCM is algebraically written. We've looked at when the LCM is a binomial expression. There's another one to it, but I'm not going to go there. Okay? I'm really not going to go there. I can make it into a binomial expansion. Alright. What did we say? What did we say we're looking at for multiplication? We cancel, yes? Cancel. Let's say we have something like this then. Say we have 25x squared y divided by 4p cube multiplied then by 8p4 cube all over 5x to the fourth y 7. And you ask to multiply that. Ooh, that's a difficult question, isn't it? No? Sansi's not shaking her head, she's not in doubt. So, we're multiplying these two. Looks very challenging. It's not. So it's multiplication. Do we find LCM? Absolutely not. We do not find LCM. What do? We look for things that can cancel out. Shade down the expression, as we call it that. Yes? I'm going to do the numbers first. Not you? And take on the letters in one by one. Yes. 25x squared y all over 4p cube multiplied by 8p4 cube all over 5x4 y7. Got it? 5x4, 5x to the fourth, y to the 7. Alright, so I'm going to take it on step at a time. Okay? Step at a time. Use a pencil. Cancel. Where's the Miss Burns? 4 into itself?
148.
128.
Oh.
Oh. Okay. 4 into 7, 1 time. 4 into 8, 2 times. Okay? You good? Not sure? 5 into itself, 1 time. 5 into 25. Are all the numbers cancelled out? Are all the numbers cancelled out, guys? Good, all the numbers are gone. Let at a time. Let's deal with all the x's then. Not sure? How many x up top? How many down at the bottom?
4.
So this is going to disappear and leave 2 down at the bottom. Does that make sense? Which does it make sense? You have 2 up top. X times x. How much down bottom? 4. Not true? Cancel, 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 cancel. How much at the bottom? So you have an x squared at the bottom. We good? Okay, x is gone. We got the y's. How much y up top? How much down at the bottom? So that gone, leave how much down here? Y to the 6, not true?
Yes.
We good? We're using the law that we learned in the first algebraic class. When you're dividing algebraic expressions, we subtract the powers. Yes?
How much were they bottom one originally?
7.
Basic class.
Oh. Are we good? Let's look at, so over here, so look like it finished. Here, so look like it finished. Let's look at the p's. How much p up top?
4.
How much at the bottom?
1.
That gone, leave how much up here?
3.
Catch it? How much q's at the bottom?
3.
How much at the top? Cancel, leave how much down here?
2.
So everything cancel out, not true? Right? Everything cancel out. So now we need to write down what is left. Conventionally, we write numbers followed by variables. Writing the variables in any alphabetical order doesn't matter. Okay? So is there a number left up top?
Yes.
Or numbers? 5 and what?
2.
So 5 times 2 is?
10.
5 times 2 is 10. Any x left up top?
P3.
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 Okay, just checking it one by. So no x, right? No y's, right? P's? 3. Okay, so that's 10 PQ. And the Q's? Over. What down here? You don't need to write 1. 1 is understood. What is left here? Q squared. What's left down here?
1.
X.
Squared.
We don't need to write 1. 1 is understood. What is left?
Squared.
X squared and y6. That's the result. You like that one, then it's not clean. You like that one, then.
I answer that?
That's it. That's it. Hold on.
That's it.
Yes.
Question.
Yes.
This is 5 times 2, right?
Yes. It's 10.
Sorry.
Hold on, hold on.
Okay, this time 3
3 by 5. The 3 is a power.
P3.
P is a 3 is a power. Coefficients multiply coefficients. Powers multiply powers.
Anytime I see it on the number.
Yeah. We got this. Cancel it out. I'm ready. 10 PQ over. So now pop up. Time up. How much time I have left? 5 minutes? No. I'm done?
Yes, sir.
You can't get one more example though. No. Hello. Sashana, 8:53. Alright. You get it? You got it? Q squared, x squared, y6. One example out of it. So that was the multiplication. I know. 15 a squared b 3 all over 2 x y fourth divided by 5a 5b 7 over 8 x y, sorry, 8 x 3 y 5. So what's the rules for division? Change the sign from division to and invert the divisor. Flip. Very fancy. 15a squared bq all over 2xy fourth changes to what? Multiplication. Flip. Flip, what goes up? 8x 3y 5 all over 5a 5b. Students in bright in time 5 minutes left in that class. Everybody at top. Class just start, class silent. Alright, so now it's time to cancel out. Not true? Numbers first. Attack them letter by letter. 5 into itself. 1. 5 into 15. 3. 2 into itself. 2 into 8. Numbers them look good, right? Hello? Numbers them good. Let's attack the A's then now. How much A up top? How much at the bottom? Knock out left. How much at the bottom? Excellent. B's then. How much B up top? How much at the bottom? Cancel out. How much at the bottom? B? 4. 3 up top, 7 at the bottom, 4 left at the bottom. Right? Alright, let's look at the X's then now. How much X up top? How much at the bottom? Cancel out. How much left up top? Excellent. Y's. How many Y here? How much up top? Cancel out. How much left up top? Excellent. Now it's time to write down what is left. It's D. Alright. Like alright. Any numbers at the top? 3 times? That is what? Okay. Any A's? Any B's? Any X's? Okay. These are X here. X squared. Y. Okay. Over. Any numbers? 1 is understood. Any X's? Any Y's? Any A's? A cube and B? Super. That completes algebraic fractions. Please feel free to review the tutorial. If you've lost in the class or you fell asleep or you're eating candy in my class, please feel free to review it. It will be available tomorrow night at 7 p.m. Bon voyage. A.M. p.m. Bon voyage, everyone. Anybody can call it test papers? Sounds interesting.
That is easy.
Right now, it's like, oh, give yourself a stress. Hold on. Look, I'll turn the camera point.
So like, things like you would always choose like one.
You have class until when? I'm not hearing you. What you say?
Bye, sir.
You have class until when?
Tomorrow.
Okay.